The lesson we're going to talk about today is solving quadratic equations by factoring. So, I want to talk about how to solve this equation right here. X squared is equal to x. Alright, now, up until this point, we've solved equations by isolating the x value, or isolating the absolute value. Those are the two methods we've talked about in solving equations this year. But this is a little different because we have an x squared and an x, and we're asked to solve for x. There's not even any numbers in this. Okay? So, if we think about this in everyday language, we have what number squared is equal to itself. Alright, and a lot of students, when they first get this question, say, okay, I can kind of think about that, but I'm not quite sure what's going on, so let me try and square root this. Alright, so they take a square root of both sides and they get the square root of x squared is x. X is equal to the square root of x. So then the question is, well, what do I do here? Now I have what number is equal to the square root of itself? And now some people can kind of get the answer from there and they say x is 1. Okay? And I say, well, you're half correct, but you're not fully correct. So I want to investigate kind of why this is not fully correct. And to understand the reasons why the solutions are what they are, you have to first understand the zero product property. So the zero product property says this. So we'll start with zero product property. And for the rest of the video, I will refer to this as the ZPP. When you see me write ZPP, I'm talking about the zero product property. Okay? It states this. If A times B is equal to 0, okay, if you have two quantities that are multiplying to 0, and A and B aren't the same number, then what conclusion can we make? Well, the only way to multiply to 0 is if one of these two quantities are 0. So then, A is equal to 0, or B is equal to 0. Alright, so if that doesn't make sense to you, pause the video and think about it. The only way to multiply to a 0 is if one of the quantities is 0. Okay? So, now I revert back to this. How does this help us answer this question? Well, we see that isolating x isn't available in this problem because we have an x squared and an x and we can't combine them in any way. So here's the process. We get a 0 on one side. I want to set up this situation. I want to have a product between two quantities equal to 0. So I'm going to actually move the x's all to the same side. So I'd have x squared minus x is equal to 0. Now at this point, I don't have the zero product property set up. I don't have a product on the left side of my equation. So how can I do that? Well, if you think about what we've been practicing for the past week, we've been practicing factoring. And factoring takes something that's a sum or a difference and makes it a product. Alright, so we can factor out a greatest common factor from x squared and x. That is x. X would be the GCF. And then what's left is x minus 1, and that's equal to 0. Now we have a product, right? This says x parentheses x minus 1, but when we read it x times the quantity of x minus 1. So by the zero product property, either x has to equal 0 or x minus 1 has to equal 0. So let's see. Well, here's a solution. We have x equals 0, or in the second case, x is equal to 1. So let's do a little check. All equations in algebra can be checked by plugging in your answers into this original equation. So if x equals, there's kind of two cases here. If x equals 0, okay, plugging in for x in our original equation leaves 0 squared equals 0. Is that true? I'm questioning, is that true? Well, obviously yes, 0 squared is 0. So that checks out. If x is equal to 1, then we have 1 squared equals 1, which checks out again. So we see that if we kind of use this approach up here, which I've seen students use year after year, and they get this answer of x equals 1, they miss that answer of x equals 0. So today we're going to be talking about how to use factoring as a method of solving quadratics. For these examples, we're asked to solve, and we're given 4 different types of quadratic equations. Okay? If we notice, this equation is in factored form. Okay? This right here is what we consider factored form of a quadratic. Okay? These are the answers. This is the way the answers should have looked when you were doing the practice problems that I assigned in the past few days. All right? So, do we have 2 quantities multiplying to 0? Yes. So that means that either this first quantity, so by the zero product property, x plus 3 has to equal 0, or x minus 2 has to equal 0. All right, then we just solve these 2 equations separately. All right, and there's our solutions. If x is negative 3, it makes this first quantity 0. Doesn't matter what the second quantity is if you plug in negative 3, because 0 times anything is 0. If we plug in x equals 2 to the second factor, this is the 0. Okay? Doesn't matter what this becomes, it is 5. Okay, we can see that. But 5 times 0 is still 0. So both of these answers satisfy this equation. All right, so next problem. Now we have 3 quantities multiplying to 0. The first quantity is 2, the second quantity is x plus 5, the third quantity is x plus 7. All right, so this is the zero product property again, and it would say, well, either this is causing the 0, this is causing the 0, or this is causing a 0. Well, obviously this 2 is not causing that 0. It's one of these 2 quantities, and we need to find the value for x that makes either this quantity 0 or this quantity of 0. So what do we do with that 2? Well, we can either ignore it, or algebraically what we can do is divide out a 2 on both sides. Okay? When you have 2 times x plus 5 times x plus 7 divided by 2, we can simply divide both of those and they cancel out to be a 1. They don't cancel out to be a 0. It's a common mistake. Okay, so our equation ends up x plus 5 times x plus 7 is equal to 0. All right, so applying the zero product property, the zero product property says that x plus 5 is equal to 0, or x plus 7 is equal to 0. So x can either be negative 5, or x can be negative 7. And there's our solutions. All right, so these 2 examples were nice because they were already factored for us. They are already set up to use the zero product property. So what if we have an equation like number 3, where it has 2x squared plus 6x is equal to 0? Well, that is not a product. That's a sum. And there's lots of different ways to add to 0. All right? So we want to make this sum a product. How do we do that? By factoring. So we're going to take the GCF of 2x squared and 6x, which is 2x, and we're left over with x plus 3, and that's equal to 0. So now we can see, now we have a product. We have the quantity 2x times x plus 3. So that means that either 2x has to equal 0 or x plus 3 has to equal 0. So in solving these separately, I get x is 0 or x is negative 3, and that's our solution. Okay? On to number 4. We have 0 is equal to x squared plus 21x minus 22. Again, we have a sum and difference equaling 0. There's lots of different ways to add and subtract and get 0. Okay? But we know by the zero product property that if we have a product, there's only one way to multiply to 0, and that's if one of the quantities you're multiplying is 0. So what I'm going to do is I'm going to factor this. Okay, this is a quadratic trinomial, so I'm going to use the factor puzzle method in splitting the middle term. So I multiply a times c. A is 1, c is negative 22, so I have negative 22 on the top of my factor puzzle. I have 21 on the bottom. So I'm finding two numbers that multiply to negative 22 and add to positive 21. So that's 22 and negative 1. Then I'll have x squared plus 22x minus x minus 22. That's what I call splitting the middle term. Then I'm going to group the first two terms and the last two terms. Remember, when you group the last two terms and there's a negative in that third term, to group that negative in. And then you can just add a plus sign here. So plus a negative is the same thing as subtraction, so I haven't changed the expression there. Now you factor by GCF in each group. So x is the GCF of the first group. We're left with x plus 22. Negative 1 is the GCF of the second group. And I'm left with x plus 22. Now this last part, to get my two factors, this quantity and this quantity both share a factor of x plus 22. So I'm going to factor that out, and I'm left with x minus 1. Now I'm in factored form. Now I apply the zero product property, which says x plus 22 has to equal 0, or x minus 1 has to equal 0. So x is negative 22, or x is 1. And that equation is solved. All right, last two examples. So the last two examples are set up a little bit differently. Notice it's still a quadratic equation, but now you have stuff on both sides. You don't have a 0. So your first step is going to be get a 0 on one side of the equation. So what I'm going to do is I'm going to move the 2x to the left and the 38, over to the left. So I'd end up with x squared. If I subtract 2x, it combines with the 8x and makes positive 6x. And subtracting 38 leaves me with negative 55. And now I have the equation set equal to 0. I'm trying to satisfy the requirements of the zero product property. So I'm not there yet because I don't have a product on the left side, so I need to create a product out of this via factoring. So a times c is negative 55. B is 6. All right, so those two numbers, I'm looking for two numbers that multiply to negative 55 and add to 6. That would be positive 11 and negative 5. So I take that 11 and negative 5 and I use that to split 6x. I split it into 11x minus 5x minus 55, and that is still equal to 0. Next, I group. Factor by GCF in each group. Okay, remember when you're factoring, the stuff in parentheses should always be the same, because that's what allows you to factor by GCF one last time at the end. So they both share x plus 11. The other factor is x minus 5. Okay, so by the zero product property, x plus 11 is 0, or x minus 5 is equal to 0. So x is negative 11, or x is 5. All right, next problem. We have 6x squared is equal to negative 27x minus 21. Now, we want to get a 0 just like we did in this problem. You have an option. You can move this 6x squared over to the left, and then you're going to be left with negative 6x squared. Or you can move these two terms to the left. The choice is yours. All right? For me, personally, I like to have my x squared term positive. All right? So I'm going to move these over to the left. And what I'm going to end up with is 6x squared plus 27x plus 21 is equal to 0. So now we need to factor because we need to create that product. Now, before you start factoring, you always have to check for a GCF. All right? And 6, 27, and 21 all share a common factor, and that factor is 3. So I factor out a 3, and I'm left with 2x squared plus 9x plus 7 equal to 0. All right, so that 3, I can either deal with it at this point and say, well, in algebra, if I do something to one side, I can just do it to the other side, and that's okay. So I can just divide out a 3. And that 3 divided by 3 becomes a 1. So I don't need to write 1 times that. I can just write 2x squared plus 9x plus 7. Right? Multiplying everything by 1 won't change it. And then the right side of the equation just becomes 0. All right? Then I just have to factor 2x squared plus 9x plus 7. So I'm going to use the factor puzzle. And I multiply a times c. 2 times 7 is 14. I need to add to 9. So my numbers are 2 and 7. So rewriting this expression on the left, I have 2x squared plus 2x plus 7x plus 7 equal to 0. All right? Then you group. All right? You factor by GCF. Factor by GCF again. So the GCF on the second group is 7. So our factors are x plus 1 times 2x plus 7. That's equal to 0. And then you're left with x's, sorry, I'm skipping a step there. X plus 1 is equal to 0, or 2x plus 7 equals 0. So solving x plus 1 equals 0 gives us x is negative 1. And solving the second equation, we get 2x is equal to negative 7. So x is negative 7 halves. All right, so this is solving by factoring. It's a method in which we can solve quadratics, and it uses the zero product property. Let me know if you have any questions, and have a good day.